Howdy, today on Flipping Science we're going to be talking about moles. Molin, calculating molin, mole high. So what is a mole? A mole is a number of things. So a dozen is 12, a ream of paper is 500 sheets, a baker's dozen is 13, a mole of something is 6.02 times 10 to the 23 of something. The reason why we use it in science is because we can use a small number to represent a large number of atoms or molecules. So it makes it easier to deal with large numbers of things. It's called Avogadro's number, 6.02 times 10 to the 23. It's named after this guy, Amadeo Avogadro, who came up with it. It's a very big number. So how big is it? A mole of dollars you couldn't spend at the rate of $1 billion a day over 1 trillion years. So that gives you a bit of an idea of its scale. A mole of marbles would spread over the surface of the Earth to a depth of 80 kilometers, which is 4/5 of the way to space. Another way of looking at it is there is a mole of milliliters in the Pacific Ocean. So it's a very, very large number. So where did it come from? 6.02 times 10 to the 23, it's the number of atoms you would have of carbon-12 in 12 grams of carbon-12. That's a bit repetitive. What it means is if you have 12 grams of carbon-12, which is one of the isotopes of carbon, inside that 12.00000 grams of carbon-12, you would have 6.02 times 10 to the 23 atoms of carbon-12. The number was devised before we figured out that isotopes existed. So now we know that isotopes existed. If you have a pile of carbon, there's a mix of carbon-12, carbon-13 and carbon-14. So we get a different mass for 1 mole of just regular everyday carbon. So if you had 12.01 grams of regular everyday carbon, that would contain 6.02 times 10 to the 23 atoms of that carbon. If we have a look at this picture down here, we can see what a mole of several substances look like. So a mole of carbons is 12.01 grams, a mole of sulfur atoms is 32.1 grams, a mole of mercury is 200.6 grams, and a mole of iron down here is 55.8 grams. So you can see they all take up different space, but in each of these amounts of each substance, there is 6.02 times 10 to the 23 atoms of those substances. So where have you seen those numbers before? You might have recognized that on a periodic table, 12.01 is the relative atomic mass of carbon. You might have noticed that for mercury, for example, 200.6, that's the relative atomic mass of mercury. So the relative atomic masses found on the periodic table tell you what the mass of 1 mole of each of those substances would be. So why is the mole useful? We can use the relative atomic masses to figure out how much 1 mole of a substance would weigh, given the chemical formula of the substance. So the best way to learn this is by doing examples. So let's look at sulfuric acid. If I wanted to find out how much 1 mole of sulfuric acid would weigh, I would add up the relative atomic masses of each of the elements in there in the ratios that they are in. So 1 mole of sulfuric acid is made up of 2 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. So if I add up those relative atomic masses, I'll get the molar mass of the sulfuric acid, the mass of 1 mole. So let's figure that out. So I've got 2 times the molar mass of hydrogen. We look on our periodic table and we can see that the relative atomic mass of hydrogen is 1.008. So that's our molar mass of hydrogen. So 2 times 1.008. And to that we're going to add 1 times the molar mass of sulfur. So if we look on our periodic table, we can see sulfur 32.06. So 1 times 32.06, and to that I'm going to add 4 times the molar mass of oxygen. Again, I look at my periodic table and I see that the molar mass of oxygen is 16. So 4 times 16. And now I look on my calculator. So go to our calculator, 2 times 1.008 plus, we don't need to do the 1 times, 32.06 plus 4 times 16. If we place enter, we get 98.076. So our molar mass is 98.076 and our unit for this is grams per mole. So this is how many grams you have in 1 mole of the substance, in this case sulfuric acid. So let's do some examples. So the first one says, what is the mass of a mole of argon? So we'll look on our periodic table, we'll find argon over here, and we can see its relative atomic mass is 39.95. So the way I represent that, molar mass of argon, so molar mass, capital M, AR, that's the symbol for argon, is equal to 39.95, and our unit is grams per mole. Alright, let's look at the next one. What's the mass of a mole of oxygen gas? So, 1 molar mass of oxygen gas, now it's going to be equal to 2 times the molar mass of oxygen. So 2 times capital M for molar mass of oxygen. So 2 times, now I'll go to my periodic table and find the molar mass of oxygen. If we look at 16, so it's equal to 2 times 16, which is going to be 32 grams per mole. Next one says, what is the mass of a mole of hydrogen sulfide? So molar mass, hydrogen sulfide, is going to be equal to 2 times the molar mass of hydrogen. So I'm just going to cut straight to the chase now. So 2 times hydrogen, which is 1.008. And to that we're going to add the molar mass of sulfur. So let's look on our periodic table again. So sulfur is 32.06. So 32.06, and I'm going to go to my calculator to help me to do that one. So we have 2 times 1.008, and to that we add the molar mass of sulfur, 32.06, and I get 34.076. So my molar mass of hydrogen sulfide is 34.076, and again our unit is grams per mole. Last one says, what is the mass of a mole of sucrose? So molar mass sucrose, which is C12H22O11, that's going to be equal to 12 times the molar mass of carbon, which remember from before is 12.01, plus 22 times the molar mass of hydrogen, which is 1.008, plus 11 times the molar mass of oxygen, which was 16. Remember, if ever you get stuck, you don't need to remember these because you'll always have a periodic table. So now we go to our calculator. So we get 12 times 12.01 plus 22 times 1.008 plus 11 times 16, and we get 342 and I'll round that off to 3. So we get 342.3 grams per mole. So why is the molar mass of sucrose so much bigger than the rest of them? There's way more atoms in here. We've got a load more atoms, so that means that the overall molar mass is going to be greater. So this one's a little bit more tricky. It says, what is the molar mass of calcium hydroxide? The tricky bit here is remembering that the 2 behind the bracket means you have 2 of whatever is inside the bracket. So our molar mass of calcium hydroxide is going to be equal to molar mass of calcium. So we're going to find that on our periodic table. So calcium is over here, 40.08. So equals 40.08. Now it's going to be plus 2 times the molar mass of oxygen, which we remember from before is 16, plus 2 times the molar mass of hydrogen, which is 1.008. So again, we'll go to our calculator. So 40.08 plus 2 times 16 plus 2 times 1.008 equals 74.096. So our molar mass of calcium hydroxide is 74.096, and again our unit is grams per mole. So today on Flipping Science we looked at what a mole is, and we also looked at calculating the mass of 1 mole of a substance. That's it for Flipping Science today. See ya.